This video explains how to use the Weighted TVEM SAS macro. Users should familiarize themselves with the TVEM SAS macro before using the weighted version.
This video is going to show a demonstration of how to use the weighted TVEM macro. And this macro is really designed to be used when you have data in which using weights can make your analysis more representative of the population. So for example, if you're using a data set like AdHealth or NESARC or other nationally representative data sets, they've sampled, people from all over the US, and then they have a sampling design with weights that if you include the weights, the data is more and your analyses are more generalizable to the entire population that the sample was taken from. And if you have this type of data, researchers generally expect you to use weights, so this macro is a way to incorporate them. And first, I just want to say that this demo video is not going to give you any guidance about picking the weights. Some complex surveys might have, especially longitudinal ones, might have several different weights that you can pick. And so if this is the case, you'll want to look into the documentation of your particular data set and get a sense of which weight is the most appropriate. And once you've selected the appropriate weight that you want to use, you can follow the steps outlined in this video. So the analysis that I'm going to show you is building off the example that was used in prior TVEM videos, so you can watch those if you want to get a sense of how to interpret the output and that sort of thing. The difference here is that this is going to include weights. So first, I'm going to read in my data and also read in the macro. And in this case, it's a separate macro from the TVEM macro that's called Weighted TVEM. And so I read these in, and then I can check here, and I have them in my working directory, and you can see that the data and the macro are there. So then I'm going to do a weighted analysis that's looking at the effect of marijuana use on depressive symptoms. And so I have the mandatory steps that you need to use here, and most of them are very similar to the TVEM macro. So if you want to go back and watch that video or have already used the TVEM macro, most of it's similar. So I'm going to show you the steps that are different. So the distribution and the data are the same. The first step here that's different is cluster. And in the weighted TVEM macro, cluster is used instead of ID. And the reason for that is because in some complex data sets, there might be a variable other than ID, a kind of a higher order level of clustering, that it might make more sense to account for rather than ID. So you can look into some of the details about your survey, and in this case we're going to use an ID variable, but in other cases some other variable might be most appropriate. Then we have the time is the same as in the TVEM macro, the dependent variable, the time varying effects, and then probably one of the bigger differences is in the knots. So the knots statement looks the same. I have a value of knots for my intercept, and then a value of the knots for my time varying predictor of marijuana use. But one of the differences between weighted TVEM and TVEM is that in TVEM you can use both B-spline and P-spline approaches, and P-spline is a nice approach to use to get started because you don't have to do model selection. In the weighted TVEM macro, you can only use B-spline, and because of that you have to do a process of model selection to pick an appropriately complex model to fit your data. So what you would do is you would start here with knots for your predictors, and then you would go through changing the number of knots for your first predictor and then changing the number of knots for your second predictor in a way that you can determine which has the lowest AIC and BIC. So for example, I'll start with 1 knot for each of these, run it, save my fit statistics, and then I would change the knots for my intercept to 2. I'd run that, I'd compare the fit statistics, and then I could do 3, 4, 5, and see which one of them has the lowest AIC and BIC, and I'd select the number of knots for that predictor. Then I would, set it. Let's say I pick 2. I would set it at 2 for the intercept, and then I would start doing the same thing for my next predictor. So I would, look at 2 knots for the intercept, and then do 1 for marijuana. And then I'd, see those fit statistics, and then I would do 2 for marijuana. And so on until I've got the model with the lowest AIC and BIC for all of those predictors. So that's a little different, but once you get the hang of it, also pretty easy to do. And then the final step, which clearly is different in the weighted macro, is where you include the weight. So you just put weight equals, and then you put in the name of the variable for the weight you're going to use. In this example, the weight is called weight, so I put weight equals weight, and now I'm ready to go run my model. So I select it, and I run it. And again, just like the TVEM model, you get results pretty quickly, though you do have to go through the model selection process. So if you scroll up, you have information about what model was run. And then here you have your fit statistics. In this case, because I have, so we have the AIC and the BIC, and we use them to determine what is our most appropriate model. And then you scroll down and you have the same kind of curves you will have in any TVEM. So here we have an intercept that is the level of our outcome for people who have a value of 0 on all other covariates. So in this case, non-users of marijuana. And then we have the effect of marijuana use and how that varies across age. So that's how you run a weighted TVEM, just a few steps that are different from TVEM, and you've got a nice weighted model. Now there's one other thing that I think is pretty useful in the weighted TVEM macro that I wanted to show you, and this is how to do analyses separately by subgroup. So because the weighted TVEM model uses procedures that are used with population data, it has a feature that allows us to run separate models for people in different subgroups while retaining the full sample weighting. So if you were to run 2 separate models, say for males and females, in the TVEM macro, you would have to split the file into a male data set and a female data set and run them both separately. But because you're running them on a smaller sample size, your confidence intervals are going to be wider, and you're going to have trouble, determining. You'll have, lesser odds of finding statistically significant differences between the 2 groups. And so this allows you to run these models separately, but maintain the sample size and weighting characteristics of the full sample. So I think this can be a really useful tool if you want to look at things by group and, for example, see the level of your outcome and how it differs for males and females. So I'm going to run the model that I just showed you, but I'm going to run it separately for men and for women using the domain and which statements for subgroup analysis. So my code looks exactly the same up until this step where it says domain. So for the domain, you put the variable that determines your group. So I have a variable called male. It's coded 1 for males and 0 for females. And so I refer to that variable that distinguishes the groups. And then there's the which statement. And the which statement refers to which level of the domain variable you want to use. So for example, if I'm putting which equals 0, I'm calculating for people with a value of 0 on the domain variable of male. And the way it's coded, that is running the analysis for females. So I run this. And I get, the results for females. They look just like the results for the full sample, but the output files that you would use for making plots of these are a little bit different. So you can see now that I've run this, I have all these files that say TVEM 0. And so these are files that are just referring to, the TVEM output for people at a value of 0 on the domain statement. So here I have TVEM 0 plot data, and that's where I will get my data for females. And so I just then would run the same thing for males, exactly the same, except I have which equals 1 instead of which equals 0. I run my model, and then I go back and see where my output is. And you can see now I have the TVEM 0 files, and I also have TVEM 1 files. And so this is people who have a value of 1 on that domain variable. And so what I can do to, if I wanted to compare males and females on, these, TVEMs that I created, I could merge the TVEM 0 plot data file with the TVEM 1 plot data file and then graph these two models together. And then you can look at where their 95% confidence intervals overlap and where they don't overlap. And at ages where they don't overlap, you can say there's a statistically significant difference between males and females. These commands are generally used when you have weighted data, but if you wanted to look at these in data without weights, you could use this macro by creating a weight variable that's equal to 1 for all individuals. And if you did that, it would run the analysis with a weight of 1 for everyone, which is the same that you would do in an unweighted TVEM. But if you do this and then use the domain and which statements, you can do a subgroup analysis, in any type of data. So I think it's a use, and then you still have the, power and smaller confidence intervals that you have by using the full sample. So I think that's the real advantage of using the domain and which statements if you want to plot values separately by different subgroups.
Thank you for watching. For more information, visit methodology.psu.edu.